Hi there YouTubers, this is My British Computer Guy here, welcome to my channel. This channel is pretty much dedicated to all things LED and also all things Warzone. So if you like computer games and you like RGB and LED lighting setups, this is the place to be. This is a fairly new foray into the RGB LED world. I recently got into it by accident after buying a gaming desktop that was full of RGB goodness and thought, why the heck can't we go ahead and do other things with this? So I basically took some inspiration from some other products that I found around the web and created these RGB sound reactive key lights. Hopefully you find the project interesting. It takes about 2 to 3 hours to go ahead and put together, minus the time it takes to glue and set the wood. But it did take a very long time to film. The filming and editing of this particular video did take a while to go ahead and do. It took me about 2 weeks to go ahead and pull everything together, so I apologize for the delay in getting this out to you. The production quality is not fantastic, but it's the best I could do with the equipment that I have right now. Hopefully, as time goes on, the videos will get better. I've got a couple of other videos in the works right now that I'm looking forward to sharing with you all, so please do hit that bell icon for notifications of when that one's going to drop. I do mention later on in this video about some aluminum V-channel that you can purchase. This is really hard to come by. You can get it on Amazon. It's a 30mm V-channel by a company called Mazada. Use the link in the description below to go ahead and find this. When searching for aluminum V-channel on Amazon or anywhere else, it all looks the same, and not very many of them have the dimensions clearly stated. So make sure you do use the link in the description below to try and to find your aluminum V-channel if you're deciding to use this particular channel for your particular project. Just wanted to stress that off the top of my head because I almost bought the wrong kind. Once again, if you do like this kind of content, and if you're a member of any groups, Facebook groups that deal with LED lighting design, or any other groups that deal with this kind of topic, please do feel free to share this video. I think it's a great starter project for somebody who's just getting into LEDs and WLED software. And I'm actually going to be posting a video here in the next week or so that shows you how to utilize the WLED software itself. That was an idea that was brought to me by one of my friends who's also getting into it right now. But without further ado, I'm going to go ahead and get into the video. As I say, please like, subscribe, and all that goodness, and I look forward to seeing you on the next one. Comments, description below, questions, description below. I'll get around to answering them as soon as I can. Thanks all for watching, I appreciate your support. You also have a great day. Cheers now. Good day, my YouTube creator family. This is My British Computer Guy here with a how-to video on how to create an RGB sound reactive key light. Now, key lights are great because they can be used as your main source of light when shooting a YouTube video. They actually cast more fill light that's soft, so it'll actually minimize any shadows. A lot of professionals use these, and a lot of professional photographers use them also. It can be used to add ambient light to a scene by placing it against a wall. So if you were to put this up against like a light colored surface, you can actually project the light from this onto the wall to give it a really nice kind of dynamic scene. And I'll show you a few pictures that I've taken around my office with using these as ambient lights. Now, the things you'll need for this particular build, there's a shopping list down in the description below. A lot of them are Amazon links and they are affiliate links, so I do get a small commission on the purchase of anything you buy via that link. However, it does not affect the price that you pay for the product. By using those links, you help support my channel. The main things that you'll need for this, obviously you're going to need some wood, and you're going to need basically at least 2 pieces of 12-inch by 1 1/4 inch square poplar dowel. This particular wood I got from Lowe's, and it was about $5 or $6 for a bag of 4 pieces. Each piece is 12 inches long by 1 1/4 inch wide, and it's nicely finished as well, so it requires minimal sanding. Other items you'll need, obviously, you're going to need some LEDs. Now, the LEDs we're going to use for this particular project, my favorite ones right now, which are the Adrazuno, I hope I'm pronouncing that correctly, LED strip. And these are the least expensive LED strips that I find that have really good quality and really good brightness. Very good color reproduction as well. These particular ones, this is a 16.4 foot roll. These are the WS2812Bs. And you get 300 on a roll. So obviously you're not going to use the whole roll on one lamp, and you'll have plenty of LEDs left over for other projects. Now, there are a lot of other manufacturers on the marketplace making these kind of systems, such as Govee. I think that's probably the most well-known of these particular brands. You can actually make this at a fraction of the cost of what it would cost you to buy a Govee setup. And also, it's a lot more satisfying to make your own. The Govee ones are a little bit shorter, and they actually cost more. What you'll need, in addition to the light strips and the wood, you're going to need a USB power supply, such as a 5-volt USB phone charger. You'll need an ESP32 chip or an ESP8266 chip. If you're going to do the sound reactive build of this particular lamp, then you'll need the ESP32 chip, as the ESP8266 chip is not supported by WLED, which is the software that we need to install on there to make this project work. However, if you only have an ESP8266, you can go ahead and still do this, but it just won't be sound reactive. Also, for sound reactive builds, you'll need a digital microphone. You can go with an analog microphone, however, I would not recommend it, as I had very little luck using those in previous builds. They would fail more often than not. The I2C digital microphone, so far I've not had any trouble with them at all. They work great. They are a little bit harder to work with, and you do have to solder them. So once again, if you're going with a sound reactive build, obviously you're going to need the microphone, so you're going to have to do some soldering. You do need the V-channel. The V-channel is a 30mm V-channel supplied by a company called Mazata, also on Amazon. Now for this, I highly recommend following the link, and the reason being there are many different versions of V-channel on Amazon. I almost bought the wrong kind. There's only one version of this V-channel that is the 30mm, and it's not terribly clear in the description or just by looking at the picture. Other things you're going to need a micro USB cable, and that's used to flash the ESP32 or 8266 chip. Obviously you'll need a soldering iron, some solder, and possibly some heat shrink tubing. The base, I did create these myself. It's custom and it was 3D printed. Each one of these bases took about 4 hours to build, and the little box there, project box that is housing all the wires, I also created that myself. So if you have a 3D printer, you can go ahead and create a base quite simply. All you need to do is make sure that you have a square opening in the middle that's no bigger than 2.5 inches square. The first thing you want to do is go ahead and flash your ESP32 drive. Seeing as I've already created an extensive video on how to do this, link in the description down below, I'm not going to be covering it in this video. There will be an extra step in the process after flashing the ESP32 drive with WLED, as you have to set up the microphone in WLED. I will post that later on in this video. When cutting the wood, if you want to go ahead and follow my exact tutorial to the T and use my dimensions, then you want to cut the wood into these sections. You want a 3-inch piece, a 4-inch piece, a 5-inch piece, and a 6-inch piece. It will leave you with one 6-inch piece left over, so if you do decide to go ahead and make another key light, you have an extra piece that you can use for the next project. Also, when cutting, what I'm going to do is I'm actually going to go ahead and bind each of the cut points with blue painter's tape. The reason for that is basically when I cut this on the table saw or my miter saw, it'll minimize the splintering. Normally poplar doesn't splinter that much, but just to go ahead and minimize any kind of splintering whatsoever, I am going to go ahead and wrap each piece on each cut point. We have a 3-inch piece, a 4-inch piece, a 5-inch piece, and 2 6-inch pieces. As I'm making 2 units, I am going to set up my miter saw with a block so I can repeat cuts. And I'm also going to go ahead and tape up another piece like this. Also, when you're cutting, if you're cutting with a miter saw, I would go fairly slow through the wood. Don't go too quickly. If you go through slowly, it actually makes it really nice and smooth. The unfinished side of the wood looks a bit average, and obviously this is going to be the base, so you won't see this. But the top, it looks really good. Minimal sanding required, and you'll see how the blue painter's tape has actually prevented it from splintering at all. I did actually wrap it quite tight around there, so yeah, it worked quite nicely. As it happens, I already had a 6-inch piece left over from another project, so all I need to do is cut one more piece of wood. So there you have it. That's all the wood that we would require for 2 key light stands. This is my build. You can make these any length that you wish. Just remember, when you're calculating the length of the aluminum V channel, take that into consideration, because one of these you're going to have to cut a groove in for the LED strips to go through. I'm going to be using the shortest one. So basically what's going to happen is the LED strip is going to be mounted on top there, so the LEDs need somewhere to run, and what I'm going to do is cut a groove. I'll show you here real quick. So the LEDs don't need much space to run. It's a fairly thin wire that's going to be going through there, so basically what we need to do is just cut off this section of the block, and to do that you can do it in a couple of ways. One, you could use a wood saw and just cut straight down. It's only 3 inches, so it won't take too long to get through, and for a hardwood, poplar is actually fairly soft, so it should cut pretty quickly. What I've done, I do actually have a jig set up on my miter saw to make it a lot easier. After cutting, you're going to be left with this. And now, when this is assembled, there's going to be some place for the wires to go. Before cutting your LED strips, you want to make sure you cut your aluminum V channel. This particular project, I've already measured it out. I'm going to be cutting 2 lengths of 19-inch aluminum V channel, which is going to sit on top of a 3-inch piece of poplar, which is also going to be set on top of a 1/2-inch riser inside the stand. So to give me my final height. The reason why I would say cut the V channel first is that you want to make sure you don't cut either too long or too short on your LED strips, because each of the LEDs takes up a certain amount of space, and obviously you don't want to be cutting halfway through an LED, and you want to maximize the amount of LEDs you get in your strip. So for this one, all I'm going to do is take a piece of blue painter's tape, find the 19-inch mark, as such, and make a line right there. Okay, seeing as I'm needing 2 pieces exactly the same length, I decided to go ahead and put a stop up against the end of my miter saw to basically prevent it from slipping, and also so I can just slide the metal down to go ahead and make an identical cut a little bit further down the piece of metal. I did also tape it a little bit more securely because the aluminum does splinter quite a bit, and I figured this might help a little bit with the splintering. But say if you don't have a miter saw, then if you've got a hacksaw, that should just or any kind of metal saw should go ahead and cut through this quite quickly, as it is pretty soft, and it's not the back is not solid. It's actually a hollow kind of V channel, so it should cut through pretty quick. Oh, and always when cutting metal or any kind of materials, wear some kind of safety protection, because you really don't want to have it end up in your eyes. And yeah, you should wear gloves, but unfortunately I don't know where mine are at. We have these 2 19-inch aluminum V channels, and we want to go ahead and figure out how many LEDs we need for them. So we want the wire to overhang just a little bit, because obviously there's going to be a connector, plastic lug at the bottom end. I'd say that's about enough. So we have 29 LEDs that we could use with it fitting. I think any more than that and we'll be cutting into another LED and it wouldn't work. So I'm going to go ahead and slice those off. Just take a nice sharp pair of scissors. Actually I'm going to use a pair of wire cutters. Because this is going to be the beginning of the next strip, we can use pretty much, I would cut towards the back, about a quarter of a way back from the center line. And that's still fine. As long as you're cutting on the pads, you're not interfering with any of the other electronics. So there we have one. And we just need another one. So again, cut as far back as you can, because the next project that you do, you want as much copper pad as you can get on there. So that is now for the next project. And now we have our two LED strips. All we need to do now is attach the connector to the LED strip. Before you go ahead and do that, make sure your arrow is pointing away from the connector. This is going to be the data flow. The data only flows one way through the strip. If you would have flipped this around and reverse wire it, the polarity would work, or the power would work. However, the data line would not work, and you would not get the desired effect. So be sure to make sure your arrow is pointing away from the connector. To go ahead and attach this, basically simply make sure the end with the metal jaws is open. Insert, push it in all the way. Now, one thing I found is these pads on this particular strip are a little bit short. So I cut back as far as I could to make sure that we have as much copper pad as possible. But when you push this in, the actual teeth are pushing into this section here. Now, I don't think there's any electronics in there or anything sensitive. I'm pretty sure it's all copper pad. But to be on the safe side, I'm going to just go ahead and push it in all the way to the back, pull it forward just a hair, probably about 1 millimeter, and then go ahead and snap it shut. Give it a tug, make sure it's on there firmly. And that's connecting to the tape. The next thing you want to do is go ahead and connect the LED wire. This is the wire that I'm using for this particular project. I'm going to be using a black 3-conductor 18 gauge wire. I pre-cut the wire to about a length of about 4 feet. All you need to do is cut back a bit of the insulation off the main cable, and do not cut back the insulation on these 3 wires. I am going to go ahead and, however, just straighten these out just a little bit, because I want them all to be the same length. Make sure you have a sharp cutting tool as well, because this connector can be a little bit tricky if you didn't get an exact smooth cut on your wires. The ground wire is closest to me. So this is the ground wire, which will be the black wire. The one furthest away, that is the positive voltage. So that's going to be the red wire, the 5 volts positive. And then the center wire, that's going to be for your green wire. Okay, so it's going to go red, green, black. All you have to do is insert each of these into the holes. Push them all the way in. Okay, once you're satisfied that they're all the way in, you can go ahead and clamp this shut, and it'll probably require a pair of pliers. What's happening when you're clamping it shut, there are some teeth on the underside of the plastic connector which are going to pierce the individual insulation for each of those wires and make contact with the copper. Crimp it from the back. Give it a tug. There you go. That's all you have to do to wire up the LEDs. Once again, remember, make sure the arrow is pointing away from the connector. I decided to go ahead and add some heat shrink cable around the connector and the base of the cable. The reason for this, I've noticed on some of my builds where I haven't used heat shrink, that after repositioning the light a few times, the wire tends to become a little loose in there and the connection becomes not quite so solid. So doing this will actually go ahead and stabilize the wire within the socket and add a little bit more pressure, and hopefully it will keep it from slipping and sliding around in there. Before gluing the wood, what you should do is take a look at each piece of wood and inspect it. Look at it for imperfections. If you see any imperfections, then you want to make sure that those are on the inside, on the glue facing sides of the stack. And then also, as I mentioned earlier, you want to make sure, take a look at the top and the bottom. One will have an obvious grain, one will not. Usually the side that does not have an obvious grain is the side that you cut, if you cut it on a table saw or if you cut it with a miter saw. If you hand saw it, it may have a bit of grain to it and you may be able to get rid of that with some sandpaper. You want to start off with coarse and then go to smooth. But the best way to get a very smooth result is by using either a table saw or a miter saw. So once we've gone ahead and decided what sides look the best for the outside, we're going to go ahead and glue the stack. Remember, you don't want a lot of glue, you only need enough to make it stick. I'm going to stick those sides together. Always glue the shortest piece of wood, because the worst thing you can do is glue up here and you're sticking it on there, then you're going to see the glue on the other side. All I'm doing is I'm just going to go ahead and position this up, make sure it's flush on that side, hold it in place for a couple of seconds, and there we go. Now I'll probably leave those to set for 25 minutes or so before I glue the final piece. When I do that, I'll come back. So, waited almost 8 hours to go ahead and have those glued. Basically, I forgot about it. So now I just need to go ahead and glue these on here, and then that'll be done for those. They may need a little bit of sanding down the seams just to smooth things out and make things nice. And then what we'll do, we'll go ahead and attach the aluminum V channels and mount the LEDs. So to glue these, again, you just need a little bit of glue, not very much, and I would kind of lean it towards the inside because you're not going to see this section. Oh, oops. More than enough. In fact, that's probably enough for both sides. Make sure that the grain side is down, smooth side is up. And put into place. And again, I say you could clamp these, but honestly, it dries pretty quick. It's got a good tack to it. I can already see that I'm going to need to sand this edge because there is a bit of a lip on there, and I'm a bit of a perfectionist when it comes to this kind of thing, and there, so I'm going to sand that smooth once these have dried solid. So I'll probably leave it maybe 12 hours, maybe overnight, before giving them a final sand. So that's literally all you need. Smooth side, rough side. A little ooze there. So if it does happen to ooze, just wipe it off with your finger or a damp rag, and then just sand it lightly with some sanding paper once they've had a chance to glue. And remember, don't worry too much about imperfections around the bottom kind of half inch of the build, because that's going to be hidden by the base. That's if you're using the base. If you're not using the base, then you may want to go ahead and sand it all down and get rid of any imperfections. The other thing, yeah, once you've got to this point, once it's all dried, you want to decide which direction you want your lights to face, whether you want the light to come this way or if you want it to go that way. If you want the light to go face, be backlighting, then you might want the wire coming out this side. If it's going to go project against a wall. If you want it to go ahead and project towards yourself as a key light, then you might want to make sure the wire goes out that direction. Or if you're smart, you could just basically put a channel across here and across here. That way you can move the wire wherever you need it. Okay, let those go ahead and dry now. Now that I've given the wood sufficient time to dry, it's time to go ahead and affix the aluminum V channel. And to do this, all you need to do is apply a small amount of super glue to this section of wood here and this section of wood here. It really doesn't take very much at all, and it bonds in, as super glue says, it bonds in seconds. This is actually Gorilla Glue super glue gel. I use this pretty much more than anything else when I'm doing these. So it works really well. So you don't need much at all. Once you've applied the glue, it doesn't need time to go off or set or anything. Make sure the back of the channel is clean and free from grease or dirt. I actually cleaned this with a bit of rubbing alcohol prior to this particular step. And all I'm going to do is hold it for probably about 15 seconds. Alright, and that, yeah, is a very tight bond indeed. It's not going anywhere. Now this particular one that I'm creating is actually a custom one for a friend. So these are actually slightly longer than the ones I normally produce. Yeah, so that's basically what you do. Just do that exactly with the other one, and then we can move on to putting the LED strips in and wiring them up to the ESP32 chip. Once everything's assembled and it's done plenty of time to dry and you've sanded off all the rough edges, if any, it's time to go ahead and mount the LED strip. Now before I do that, I'm actually going to take some rubbing alcohol and a bit of paper towel and wipe down the aluminum V channel, mainly just to get rid of any grease or anything that might prevent the LED strip from adhering properly. Honestly, I'm sure it would have been fine, but there's a lot of dust in my workshop, so it's been sat here for a day. I've taken a break from the project, so let's go ahead and just get any dust off there. Okay. Next, you want to take the LED strip and you'll flip it over, and as you'll see, it has this blue sticky, this like blue plastic protective tape film. I'm going to make a very slight incision right down here, just to be able to go ahead and peel that back. Just a little. There you go. So once you've made the incision, just go ahead and peel it back about 1 inch, and then we're going to go ahead and feed it through. The base of the lamp. Carefully does it. Sure it all goes the full length, which it does, or a bit of room for the end cap, and then all we have to do is remove the blue tape from the bottom and then mount it in the middle. making sure you keep it in as close to the center line as possible, as close to the center of the channel as you can. And this stuff is really tacky, it's really sticky, it will stick really well. If you make a mistake and you have to untack it from the channel, you probably can do it about once. After that, if you try and reapply it again, you'll start have difficulties. You may have to end up using a hot glue gun. So the key is just to go ahead and get it right the first time. Okay. There we have it. Now, one last step before we start hooking wires up. Once you've gone ahead and got the LED strip in there, what we want to do now is put a little bit of some protection on it to stop it from stopping the cable from being accidentally yanked out. To do that, what I've done is taken a regular, just a little old zip tie, and tied it around the end here. This is kind of loose, it's not tight, and I did leave a little bit on there so I can get my pliers on there and cinch it up. But what I want to do, I've created I'm calling this a retention plate or a retainer plate. And it's going to basically slide over the wires here. And this was just a little something I 3D printed, put together pretty quick. It took like 5 minutes to print. And the idea is you slide it down the cable, and then use it to push up the zip tie just to about till you get to a point where you can actually, there you go, to about there. Okay. So that's fairly loose, so we can just pull that back. And now what I want to do is go ahead and cinch up the zip tie on there so it stays in place, and that will basically prevent that wire from being tugged out once that little retaining plate's been fixed in place. That now, it's not going anywhere, and I can cut the end of that off. Tidy things up. Okay, so now all we have to do is slide this plate down and fix it in position with 3 little screws. So now that the retainer plate is on there, that cable is not going anywhere. Part of the core of this project, being a sound reactive project, is the fact that it uses a microphone. This is the microphone we're going to be using. Links in the description down below. It's a digital microphone. This is not the analog microphone. A lot of the YouTubers that have done sound reactive projects with WLED and ESP32 use an analog mic. I did use an analog mic in my first build, but experienced a lot of problems with it. Sometimes it would work, sometimes it wouldn't work. So basically I did some research and found out that the digital mics are a lot better for this build. They're a lot more sensitive and they work like almost, I would say, 100% of the time. I've not had any issues with them. It is a little bit more complex to wire, so I'm going to go ahead and show you how to wire it up, and I've got a schematic that will show you where all the wires go. So if you bear with me for a second, I'll go ahead and bring that up. The wire that we're going to use for this is a little bit different from the wire that we use for doing everything else on this particular project. We're actually going to be using 20 gauge solid core wire. This is just a fairly inexpensive brand that I found on Amazon. The reason we're using 20 gauge is because if you'll notice that the holes on this microphone, they're really small. And honestly, anything bigger than 20 gauge is not going to work. And honestly, if you were to use a 20 gauge stranded conductor, you'd probably have a really hard time twisting those strands to get them through those holes. So I'm going to go ahead and use this solid core, and it's also pretty good for positioning the microphone once you've got it in situ, once you've finished the project. So I'm going to start off with the ground wire. Ground, I always use black for ground. We're just going to go ahead and preheat the actual wire itself, and then apply a little bit of solder at the base. So I'm using a very thin solder. This is 0.015 in diameter. Just apply a little bit of heat to the pin. I didn't pre-tin these because if you pre-tin them, they're just not going to fit. The GND was the ground, and then we used the red wire to go in the VDD. Apply a bit of heat. So the configuration as we have it so far is the black has gone to the ground, the red went to the VDD, which is your positive and your negative terminals, and then the SD is going to be green. And the SD basically is the input that goes to the ESP32 that carries the actual signal from the microphone. So we're going to go ahead and do this one next. Alright, so next we've got the WS and the SCK. And those are the only other two pins that we're going to be using. We do not use the L/R. I'm not exactly too sure what that one does, but we don't need it. And that middle hole, by the way, is actually the microphone itself. So try and keep any dirt and debris out of there, and don't try and stick a wire through it, otherwise you'll damage it. So we're going to use yellow for the WS, and then we're going to use blue for the SCK. So let's go ahead and do the yellow one first. So the final pin is the SCK, and for that we're going to use a blue wire. The only thing that's left to do on there now is go ahead and trim a couple of those wires down, probably the one from the VDD and maybe the SD pin. The other one's actually looking fairly okay. So the next thing we want to do is go ahead and attach this to the ESP32 chip, and I'll show you how to do that next. After you've wired the microphone, you're going to want to go ahead and attach the microphone to the ESP32 chip, and I'm going to put a pinout diagram or schematic up here in a minute, but just to give you a quick walkthrough of what we're going to do. So on the red wire from the microphone is the positive voltage, and that's going to go to the 3V3 pin in the upper right hand corner here. The black wire from the microphone is going to go to the GND pin, okay, and then on the other side, the green wire, which is wired to the SD on the microphone, is going to go to the D33. We'll see it here. The D33 pin right here. The yellow wire is going to go to the D25 pin, and the blue pin is going to go to the D26 pin. So I'm going to start off with the D26 pin, and this goes to the SCK pin on the microphone, and D26 is the pin on the chip. I've pre-tinned, so hopefully it's just a simple case of adding a little bit of solder like that. I've added heat shrink to each of these cables prior, so all I've got to do is slide up the heat shrink, slide it over. So we added a little bit of heat shrink to this prior to going ahead and soldering it on there, and this basically will just shrink up around the pin and the solder joint, just to prevent it from accidentally touching anything else or any of the other pins. I've actually added heat shrink to each of the wires coming off the microphone. So to tin the wires, all I did was wrapped a bit of this solder over the wire and went ahead and did that. That's just enough to go ahead and get it tinned. There are a couple of different ways of doing this, but I found that this works the easiest. This solder actually has built-in has flux built into it, so it adheres quite well. The next wire we're going to be soldering is the yellow wire, which comes from the WS output on the microphone. This goes to the D25 pin on the ESP32. So green to D33. There he goes. This is a pin I haven't tinned on the ESP32 chip, so I'm just going to show you how to do that real quick. So it's pretty straightforward. Just apply a little bit of heat to the leg. Don't worry too much about melting the black plastic on the pin header. That should be okay. Then lastly, you need to go ahead, for soldering the microphone, you need to hook up the black wire to the ground pin. So the black wire goes to the pin directly next to the 3v3 pin. Now we just have to heat shrink those. Okay, so once you're all said and done and you've finished with your soldering, you should have something that looks like this. While I'm in the soldering mood, what I'm going to do next is I'm actually going to go ahead and take three 18 gauge wires, and this is the stranded wire which I use for the LED strips for connecting pieces of that together. I'm going to go ahead and attach a positive and a negative wire to the ESP32 chip to give the ESP32 chip power. That will help supply power. Then I'm going to go ahead and attach the data cable. This is where we have the output from the ESP32 to the LED strips. You'll notice how the solder is drawn straight into the wire. Okay, we're going to be using the N2 pins, the VIN pin for the positive, which is the red wire, and the pin next to it, which is the GND wire, we're going to be using that for the black wire. So we'll start off with the positive. And then the negative. And then we're going to add a bit of heat shrink around those. So last but not least, we go ahead and wire up the D2 pin. This is the fourth pin over from the power wires that come from the microphone. The D2 pin is basically where the ESP32 chip outputs the signal to the LED strip, telling it what to do. So it's been pre-tinned. Just go ahead and hold that against there. Good secure connection, and then add some heat shrink. Okay, so now we have all the wires connected that we need. There's no more soldering that you have to do. You can use Wago connectors from this point forward. All that basically happens now is this wire here and this wire here go to your power supply, and this wire here goes to your data input line on the LED strip. Also, you'll need to run a wire from here and here to the positive and negative terminal of your LED strip. Once you've done that, you're pretty much good to go. At this point in the video, I'm going to go ahead and show you how to make a USB power cable using a blank male USB-A connector. Now, even though I'm showing you how to do this, I'm actually not going to make that recommendation that you do this for this particular build. And the reason being, after having gone through the process of making a USB power cable with these particular connectors, the problem I found is that the hole where the wire goes is not big enough for the actual wire itself. These do not fit a 20 gauge wire, definitely not an 18 gauge wire, maybe a 24 gauge or a 28 gauge wire, but honestly we don't want to use those for this particular project. So what I would recommend, instead of going ahead and going through the hassle of making your own, go ahead and buy some. There's a company on Amazon that sells these. They come in various lengths and in packs of 2. They're fairly inexpensive and they look much more professional. I can't pronounce this company name, and I don't think they know how to measure. These are the 12-inch versions, but they're a lot longer than 12 inches. I'd say these are probably like 14-15 inches, but they are much more professionally finished, and it's a solid, feels like an ABS, or I'm not too sure what it is, but it's a much nicer connection. And the ends where the power is, they've been pre-tinned, so it makes for easy soldering. But definitely go this route versus the making your own route. I will leave the instructional video on how to make your own power cable in case you do decide to go that route, but I do not recommend it. We now need to go ahead and create a USB power cable. To do that, it's pretty simple. You just take a blank male USB connector that's not being used, and we're going to cut about 1 foot of power cord. Now this power cord is the one I showed you earlier. This is a 20 gauge 2 conductor, so it's basically got a red and a black wire in it. It is 20 gauge, not 18 gauge. The reason for that, we're actually only going to be powering this light with a USB connector. These connectors, power adapters, typically only output a maximum of about 2.5 amps, which is sufficient to be able to run through 20 gauge wire without any issue. The LEDs are going to be told how much current to draw by the software, and we're going to basically just set it so it's no more than 2.5 amps, which is the maximum that this can output. You do have an option if you wish to go ahead and power the lighting with the onboard USB socket, which is a micro USB connector. However, if you decide to go that route and not create your own cable, you are limited as to the amount of power you can push through. The LEDs can only draw up to 1 amp if you're powering through this particular socket here, which basically means if you're powering from that wire going through the circuit, the maximum that you can go through there to the LEDs is 1 amp. Any more than that and it will actually fry the circuit board, because it's going to put too much of a demand on the circuitry to pull more than an amp. However, what we're doing here is we're actually bypassing this, and we're just basically going to attach power cables to these. So this powers the chip. The power running to these will also power the LED strip, and that's what we want. So here we go. Alright, so we have a foot of cable. Now we just need to go ahead and strip that back a little bit, and we need to we're going to go ahead and start off by tinning the wires. We're also going to go ahead and tin the USB connector itself. And each of these connectors have a little tray in them where the wire goes. So what we're going to do is heat up the little tray. And we're only interested in the outer 2. And then the thing to note is that the negative is the one that's furthest away, the positive is the one that's closest to me. These wires are a little bit too long. I'm going to go ahead and cut these back just a hair. To about that length. And the other thing I've got to be mindful about is actually how long we're going to go from the wire to the end of the USB, because these connectors, they're designed for thinner gauge wire than 20 gauge. So I'm going to go ahead and cut the protective coating about there. And what we'll do, we'll put a bit of heat shrink on this, like so, and heat shrink's going to go between here and here. Okay, so what we have to do now is just heat the little tray up, get that solder nice and runny. There you go, drop in the wire and it's all set. Okay, rinse and repeat. There we go. Okay, so the wire is now successfully in there. Let's do a tug, it's fine. It does have metal flaps on here that you can fold over the wires to give it a little extra stability, like so. Okay. So we can get an idea, make sure we're still at the right length. And the reason for the heat shrink tubing that I'm going to be putting on here is basically to stop these wires from chafing on the plastic coating, and just to really kind of give it a little bit more sturdiness over time. Unfortunately I don't have any black, so I'm using some red. And this is 2 times shrink, because the 3 times shrink that I had was terrible. Again, that should be enough. And then use our soldering iron or whatever heating implement you wish to use, and just shrink it down. Okay. So that is now pretty much it as far as the USB cable is concerned. We just need to bare the other end, and then we can go ahead and start hooking things up to the LED strips. That should now fit in there quite nicely. There you have it. There's still a little bit too thick there. I may end up on the next one using a small drill just to bore out some of the plastic on that, just to make it a little bit snugger so it looks a bit more polished. In fact, I'm going to go ahead and do that. There you have it. Ideally that would be a little bit of black, bit of heat shrink, but as I don't have any, that's all I can use. So now we just have to go ahead and strip back this wire, and then we can start hooking up everything to the ESP32 and the LED strips. So you have a couple of options when wiring your ESP32 to your LED strip. You can either go ahead and solder the connections, which I'm not going to do right now, or you can use Wago connectors. Wago connectors offer a huge time-saving advantage in the fact that obviously there's no solder required, and you basically just clip them on the wires and they stay pretty firmly in place. I use them a lot of the time for shortcuts, but they are these are official. They work really well. So what I'm going to do, I'm going to show you how to hook up everything with Wago connectors. Now normally I would actually be installing this project in one of my little 3D printed project boxes, but I'm going to do that afterwards and I'll show you the end result, because I'm actually going to go ahead and solder this after I've done this demonstration. The demo is just really to show you how this hooks up and all hooks together so you can get power to your LED strip, and so you can see that the microphone is working. So it's pretty simple at this point. You've done all the hard work. So you need 2 3-way Wago connectors and 1 2-way Wago connector. And the simple solution to this is basically you just hook up all the colors in turn to a Wago connector. So for example, we'll start off with the black. Okay, you're going to hook a 3-way to the black, a 3-way to the red, and a 2-way to the green. And the reason there's only a 2-way to the green is because you only have 2 data wires. Okay, next we'll hook up the power. So the power goes black to the black. Make sure they're all the way in there, and you give them a little tug to make sure that isn't snug. Red goes to red, and that's that. Now we have the ESP32 chip with the microphone. Black goes to black, and green goes to green. And red goes to red. And there is a gauge on the side of these Wago connectors that shows you how short to cut these wires. Try not to go any longer than that, because otherwise the wire will hang out and it potentially could short against another wire in the box. Okay, now that everything's hooked up, all we have to do is supply power, and provided that the LED strip and the ESP32 chip is already been flashed, then you should be good to go. Okay, so let's plug it in. And there we go. The ESP32 chip is up and running and functional. One thing to remember, when you get into the app, you will have to go ahead and assign how many LEDs are in your strip into the WLED app. By default, I believe it says 30. This particular strip has 29, so obviously it's going to go, even if it's programmed for 30, it'll fully light up, but you want to go ahead and adjust that so all your effects work properly. So lastly, all we need to do is just go ahead and cut the diffuser, and once you've cut the diffuser and mounted it, there is actually a plastic backing on here that you need to take off. To go ahead and measure it, all really I've been doing is just kind of holding it up against the base. And then marking with a Sharpie on the back. Just a little mark there, and a little mark there. And then all you do is take some tape and put them from line to line. Because I know the tape's straight, it'll help me cut a straight line. Trying not to stretch the tape. Between those 2 points is my cut line. If I cut along that, then I know I'm going to get a straight edge, because this does tend to bow a little bit when you cut it. Take tape off, and that should also take the, oh wait, maybe not. Get the plastic backing off. Time for a bit of ASMR. All right. Then all we do is mount the channel in the groove at the bottom. Can be a bit tricky. Slide it along. There we go. Then all we do is put on the end cap. I 3D printed some replacement end caps for these Mazata 30mm. Just go on like so. And there you have the finished product. All that's left to do now is plug it in. Once you get to this point, there's only a couple of things left to do. First of all, we need to go ahead and set up the WLED app. The LED app needs to know which pins on the ESP32 have the microphone. So to do that, what you want to do is plug in the RGB key light, give it a few seconds, then head over to your phone. Go to your phone and under Network Settings, find the network that is called WLED app. Once you've clicked on that, it may prompt you for a password if it's your first time signing in. The password is all lowercase, WLED1234. Once you've signed in, it should automatically take you to the welcome page for WLED. When you get there, go ahead and select To the Controls. On this screen, you want to go ahead and select the Config option in the upper right hand corner. Then select Sound Settings, and then under the Sound Input Pin Manager, make sure the microphone type is set to Generic I2S. Once you select that, it's going to go ahead and give you the option to enter values for the SD, WS and SCK pin. Make sure the SD pin is set to 33, the WS pin is set to 25, and the SCK pin is set to 26. Once all those values are in there correctly, go ahead and hit the Save button. Give it a second and then unplug the ESP32. Once you plug it back in again, it should be good to go. To go ahead and set the correct number of LEDs for your particular project, what you'll need to do is, first of all, go ahead and connect to the ESP32 or your ESP8266 via the Wi-Fi menu. Then click on Go to the Controls. When you go to the Controls, the first thing you want to do is go in the upper right hand corner and click the Config button. Then go ahead and select LED Preferences and then scroll down to Hardware Setup. And under Hardware Setup, it says LED Outputs. The second or third item down is Length. That dictates the number of LEDs in your strip. For this particular project, I believe it'll be 29. Other settings on there that you might want to be aware of: the color order that's directly above the length. If for some reason your LEDs do not light up in the right order when you're using the effects, so say for example you choose red and it shows up as green, or you hit blue and it shows up as red, then the color order could be incorrect for the LED strip that you're using. Now, BTF lighting LED strips and the Adrezuno strips all use the GRB color profile for color order, so you should be fine there. The only other thing on here to be aware of is at the top of this particular page. Here you can actually control the maximum amount of current that flows through your power supply to the LED strips. Typically, you'll want to go ahead and set that to a fairly low number, especially for a project like this. So a good rule of thumb to calculate how many milliamps of power you need is to basically take the number of LEDs and times that by 0.06. That will give you the number of milliamps required to go ahead and power your project at full white brightness. Now keep in mind, if you're powering your LED strip through a USB charger through the USB port on the ESP32 or ESP8266, do not set that value to more than 1000 milliamps. If you do, it will cause the chip to burn out. The way we've wired this particular project, because we're using an external power supply from the USB, we're not powering it via the USB port on the ESP32. You can actually set that value, that maximum current, to the maximum amount of milliamps that your USB charger outputs, and that should be more than enough for this particular project. Never go higher than the rated output for your particular charger. Well, congratulations, you made it to the end of the video. Hopefully you now have a fully functioning RGB key light, or maybe even two of them. Hopefully it didn't take you too long to build. I feel that the video was fairly thorough. If you still have questions or concerns, or something's not working quite right for you, please do feel free to leave a message in the comment section down below, and I'll try and do my best to answer it as quickly as I can. One thing I wanted to bring to mind is the WLED app that's pre-installed when you flash the ESP32 or the ESP8266 is a little bit buggy. For some reason, when you try and go to the color menu or the effects menu and you try and scroll, it'll try and refresh. It does this all the time on my phone. I've got a Galaxy S23 Ultra, it's an Android device. I don't know if it's just limited to this device or if it's happening on all devices. I don't know if it's also happening on Apple devices either. The way around it is to go ahead and download and install the dedicated WLED app from the App Store or the Google Play Store. I found that there's no issues with that whatsoever, and I will go into more detail on how to use that app in an upcoming video. I want to say thank you for watching the video. I truly appreciate you making it this far. Hopefully you had a good experience. I'd love to see pictures or your own videos or interpretations of this particular build on your own YouTube channels. So if you do decide to go ahead and do that, please reach out and send me a message or a link in the description, and I'll be sure to go ahead and check it out. Lastly, please like, please subscribe, and hit that bell icon. It means a lot. I'm trying to get my subs up. Anything would help, and definitely use those links below, especially the one for the 30mm aluminum V channel. As I say, it's very difficult to get the right one, or to make sure you got the right one, because they don't put all the dimensions in the photographs. Well, they didn't the last time I bought some, so please be sure to go ahead and make sure you use the right link, or you buy the right V channel. If I can help with anything else, just send me a message. Other than that, I'll see you in the next video. Thanks for watching. Take care now. Bye bye.